He wasn't trying to win a war that morning. He was trying to fix something everyone else had already accepted as normal. Under the wing of a bomber that kept failing the same mission in the same way. He watched men weld parts that were never meant to be there, knowing the manual said this should not work, and the engineers would have shut it down if they had seen it. The system had already decided what air combat looked like, and it wasn't this. But he had seen enough failed runs, enough aircraft not come back, to realize the real problem wasn't the enemy. It was the way they were thinking. So he made a small change, one that didn't look like much at the time, and in doing so, he set something in motion that no one in command could fully control once it started. Months before anyone tried to explain that strange result at sea, the pattern had already been visible to the people closest to the aircraft. The ones who had to touch every damaged panel and count every bullet hole that came back from missions that were supposed to work. High-altitude bombing had been the accepted method, written into manuals, taught in training, repeated in briefings with absolute confidence. Yet the reality unfolding over the waters near New Guinea told a different story that no one at higher command seemed willing to fully confront. Bombers flew in at thousands of feet, released their payloads based on calculations that looked precise on paper, and then watched as ships simply turned, adjusted, and kept moving, while the bombs fell into empty ocean. When crews attempted to descend lower, to improve accuracy, the defensive fire from ships tore through them before they could complete the run, leaving behind wreckage and reports that quietly contradicted everything the system claimed to know. On the ground, those contradictions accumulated in ways that statistics never fully captured, because numbers could be explained away, but patterns could not, and the men who worked on the aircraft began to notice those patterns long before anyone officially acknowledged them. Among them was a crew chief named Jack Turner, a man whose job was not to question doctrine, but to keep machines operational. Yet he had started to recognize that the aircraft were not failing randomly. They were failing predictably, returning with damage that followed the same angles, the same entry points, the same signs of exposure during the final approach. From his position, the issue did not look like enemy superiority. It looked like a design problem in how the missions were being executed, a gap between what the aircraft were built to do and what they were being asked to accomplish in real conditions. Turner was not alone in seeing it. But the system around him was not designed to absorb that kind of observation from someone in his position, because insight was expected to flow from strategy downward, not from maintenance crews upward. And so the conversations that happened on the flight line rarely traveled beyond it. Pilots would mention the same frustrations after missions. Navigators would question why their calculations never seemed to match reality. Yet each of those concerns was treated as an isolated issue rather than evidence of a larger flaw, and the official response remained consistent. Refine the technique, trust the method, repeat the process. The result was a cycle that reinforced itself, where failure did not lead to change, but to repetition, and repetition only produced more evidence that something fundamental was wrong, though no one in authority framed it that way. Aircraft were repaired, crews were replaced, missions were scheduled again with the same expectations, and each time the outcome drifted further from what had been predicted, creating a quiet tension between what the system insisted was correct and what the people inside it were actually experiencing. Turner would later describe it not as chaos, but as something more unsettling, a kind of structured failure where everything looked organized, everything followed procedure, and yet the end result kept pointing in the same direction. In that environment, the absence of a solution became its own form of pressure, because the longer the pattern continued, the harder it became to ignore, and the more dangerous it was to challenge openly, especially for someone without rank or authority to back it. What made the situation more fragile was that the system itself did not recognize the urgency of the problem, because on paper the strategy still appeared sound, the doctrine remained intact, and there was no official moment where anyone declared that the approach had failed. Instead, the recognition existed only at the edges, in the observations of people like Turner, in the brief comments exchanged between missions, in the growing awareness that the enemy was not exploiting a weakness by chance, but was responding to a predictable method that had never been questioned at its core. And it was within that gap, between what was written and what was happening, that the conditions were set for someone to see the problem differently, not as a tactical adjustment to be made within the system, but as something that required stepping outside of it entirely, because as long as the same assumptions remained in place, every new attempt would only produce the same result under a different set of circumstances. There was one person on that flight line who did not interpret those patterns as something to be worked around, but as something that exposed a deeper misunderstanding, and his background made that difference unavoidable. Paul Gunn had not come up through the same pathway as most of the officers around him, and that mattered more than anyone realized at the time, because his instincts were shaped long before the war by problems that could not be solved by doctrine alone. He had built and operated aircraft in civilian conditions where efficiency was not theoretical, where every modification had to prove itself immediately or be discarded, and where the question was never whether a system was correct, but whether it worked under pressure. When Gunn looked at the bombers being sent out over open water, he did not see a formation executing a textbook maneuver. He saw a mismatch between design and purpose, an aircraft configured for one kind of engagement being forced into another without adjustment. To him, the issue was not that the crews lacked skill or that the enemy was unusually effective, but that the aircraft were being asked to perform a task that their current configuration did not support. And that insight came from a kind of practical reasoning that had little to do with rank or formal authority. It was the same reasoning a mechanic would use when an engine kept failing under specific conditions, not by blaming the operator, but by questioning whether the system itself needed to be changed. Gunn's conversations with people like Turner were not formal briefings or strategic discussions. They happened in fragments between repairs, in observations about how the aircraft behaved when pushed beyond what they were originally designed to do. Turner had noticed the damage patterns. Gunn asked why those patterns kept repeating, and together they began to frame the problem in a way that did not fit within the existing structure of command, because it implied that the solution would not come from refining current tactics, confirmed kills, but from altering the aircraft itself in ways that had not been approved. That distinction was critical because changing tactics could be authorized within the system, but changing the machine challenged the assumptions behind those tactics, and that was where resistance began to form even before any physical modification took place. What Gunn proposed, at first, did not sound like a breakthrough. It sounded like a workaround, the kind of adjustment that might solve a local issue without addressing the larger framework, and that perception made it easier for others to dismiss it. He was not presenting a new doctrine or a formal strategy. He was describing a way to bring the aircraft closer to the conditions it actually faced during an attack, reducing the gap between theory and reality by shifting how the aircraft delivered its firepower. The key difference was that Gunn was not thinking in terms of altitude or formation. He was thinking in terms of interaction, how the aircraft and the target influenced each other in the seconds that determined whether a mission succeeded or failed. This way of thinking came directly from his civilian experience, where machines were tools to be adapted rather than systems to be preserved. And that perspective allowed him to see possibilities that others overlooked, not because they were incapable, but because they were trained to operate within boundaries that defined what was acceptable. Gunn did not ignore those boundaries out of defiance. He simply did not see them as fixed, and that subtle difference meant that he approached the problem from a position that the system itself could not easily categorize or control. The first adjustments he considered were not dramatic. They were incremental, focused on how to increase the aircraft's ability to project force forward during the most vulnerable phase of an attack, when descending to a level where accuracy became possible, but exposure increased sharply. From a purely mechanical standpoint, the idea made sense, but from a structural and procedural standpoint, it introduced complications that no one had formally accounted for, including weight distribution, stability, and the impact on how the aircraft would handle under stress. Those concerns were not theoretical objections. They were real risks, and in a system that prioritized predictability, introducing that level of uncertainty without full validation was seen as a step too far. Turner understood those risks as well as anyone, because he would be the one responsible for dealing with the consequences if the modification failed, and yet he also recognized that continuing without change carried its own kind of certainty, one that was already visible in the damage reports and the aircraft that never returned. That tension between known failure and uncertain improvement created a narrow space where a decision could be made, not based on approval, but on necessity. And it was within that space that Gunn's approach began to take shape, driven less by the authority to act, and more by the inability to ignore what had already been observed. The moment that mattered did not arrive with an order, a meeting, or a formal approval. It happened in the kind of silence where decisions are made, because waiting any longer would only repeat what had already failed. The modification itself did not look like a turning point when it began, because it was not introduced as a solution to the entire problem, only as an attempt to change one specific moment in an attack, the brief window when an aircraft was most exposed and least effective under its existing configuration. Gunn focused on that moment with a kind of precision that came from understanding machines at their limits, not in theory, but in how they behaved when pushed beyond what they were originally designed to do. Instead of asking how to improve bombing accuracy within the existing framework, he approached the situation as if the framework itself had already been disproven by experience, and that shift in thinking led him to a single adjustment that seemed almost too direct to be taken seriously. If the aircraft were vulnerable during the approach, then they needed to project force forward before reaching the release point, not as a secondary function, but as the primary way to control the engagement. That idea did not require a new aircraft or a new strategy. It required changing how the existing aircraft delivered its firepower. And that meant physically altering the nose configuration in a way that had not been part of its original design. The decision to proceed with that change did not come with certainty, because the risks were immediate and measurable, and they extended beyond whether the idea would work in combat. Adding heavier forward-mounted weapons would shift the center of gravity, affecting how the aircraft handled during takeoff and flight, potentially making it unstable or difficult to control under load. The structural stress on the airframe would increase, and there was no formal testing to predict how those stresses would distribute over time. From a system perspective, these were not minor concerns. They were the kind of variables that justified rejecting the modification outright, and in a fully controlled environment, they likely would have been enough to stop the process before it began. Turner saw those risks take shape in real time as the work progressed, not as abstract calculations, but as physical changes that altered how the aircraft sat on the ground, how its weight shifted when components were added, how the balance that pilots relied on was being adjusted without the support of established procedures. Each piece that was installed brought the aircraft further away from its original configuration and closer to something that had not been validated by anyone outside that flight line. The absence of approval was not a technical issue. It was a structural one, because it meant that if the modification failed, the responsibility would not be distributed across the system. It would fall directly on the people who had chosen to proceed. What made the situation more complex was that the system itself was not entirely unaware of what was happening, but it responded in a way that revealed its priorities. Reports of unauthorized modifications began to circulate, accompanied by concerns about safety, balance, and the long-term impact on aircraft integrity. And those concerns were valid within the logic of the system, which valued predictability and standardization. From that perspective, the modification represented a deviation that introduced unnecessary risk, especially when there was no guarantee it would produce a better outcome than existing methods. The expectation was not that the idea would be tested and refined, but that it would be stopped before it created complications that could not be controlled. Gunn understood that response, but he also recognized something that the system did not account for, which was that the existing method already carried a level of risk that had become normalized, simply because it was familiar. The difference was that the current approach failed in a way that aligned with expectations, while the modification threatened to fail in a way that had not been predicted, and that made it more difficult for the system to accept, even if the potential benefit was greater. In that sense, the decision to move forward was not just a technical choice, it was a shift in how risk was evaluated, prioritizing the possibility of change over the certainty of repetition. The first time the modified aircraft was prepared for flight, the tension was not about whether it would succeed in combat, but whether it would function at all under conditions that had never been formally tested. The balance felt different. The control inputs required adjustment, and the aircraft responded in ways that confirmed the concerns that had been raised. Yet it also remained airborne, which was enough to move the process one step further than the system had intended. That single step did not resolve the risks. It redistributed them, placing them into a new context where the question was no longer whether the modification should exist, but what would happen if it continued to develop beyond that initial test. And in that moment, without a formal decision or a clear point of authorization, the change that had started as a small adjustment began to take on a different significance, not because it had been proven, but because it had not been stopped. And that absence of interruption allowed it to move forward into a space where its consequences would no longer be theoretical. When the modified aircraft were finally committed to a real mission, the tension was not about facing the enemy. It was about whether the change would hold together under conditions that had already exposed every weakness in the original approach. The crews assigned to those aircraft understood that they were not just flying a different configuration. They were testing an idea that had never been validated within the system they operated in, and that meant there would be no fallback explanation if it failed. The plan itself reflected that shift, moving away from distance and calculation toward proximity and timing, requiring the aircraft to enter a space where every second mattered and every adjustment had immediate consequences. The conditions over the Bismarck Sea did not offer any advantage that could compensate for uncertainty, with weather-limiting visibility and the convoy maintaining movement that had previously made accurate bombing nearly impossible from altitude. In earlier missions, those factors had worked against the bombers, reinforcing the limitations of the established method. But now, they created a different kind of environment, one where closing the distance could reduce the unpredictability that had defined previous attempts. The decision to approach at low altitude was not new in itself, but combining that approach with forward-focused firepower changed the interaction between aircraft and target in a way that had not been tested at scale. From the perspective of the crews, the most critical phase of the attack began before any bombs were released. During the approach, where the aircraft had to maintain a trajectory that brought them within effective range while remaining exposed to defensive fire. In the past, that phase had been the point where missions broke down, where accuracy came at the cost of survivability, and where the system's assumptions about how bombers should operate no longer aligned with what actually happened in combat. The modification directly addressed that moment, allowing the aircraft to influence the engagement before reaching the release point, not by avoiding fire, but by disrupting it long enough to create a narrow window of control. Turner, observing from the ground after those first sorties, would later focus less on the immediate results and more on how quickly the pattern of interaction changed once the modification was introduced. Aircraft returned with different types of damage, not because the enemy had become less capable, but because the engagement itself had shifted, altering the timing and direction of exposure. That change was subtle in description, but significant in effect, because it meant that the vulnerability that had previously defined the mission was no longer fixed. It could be influenced, adjusted, and in some cases reduced by how the aircraft was configured and flown. As the attacks continued, the accumulation of those small differences began to produce outcomes that diverged sharply from previous expectations. Not in a single dramatic moment, but across multiple engagements, where the same approach yielded consistent results. Ships that had once been able to maneuver through bombing patterns found themselves reacting earlier and under pressure. Crews that had relied on predictable attack profiles faced a different sequence of events. And the overall dynamic of the encounter shifted in a way that could not be explained by chance alone. The effectiveness of the approach did not come from overwhelming force in the traditional sense, but from changing the order in which events unfolded, compressing the time available for the target to respond and expanding the control the aircraft had during the most critical seconds. The significance of that shift became clearer as reports moved up through the system, because the outcomes could not be easily categorized within existing frameworks. What had been expected to require sustained effort and multiple attempts began to occur within shorter engagements, and the consistency of those results suggested that the change was not situational, it was structural. Yet, this created a new form of tension, because acknowledging that effectiveness meant confronting the fact that the previous method had been fundamentally limited, and that the improvement had come from a modification that had not followed the standard process of validation and approval. For those who had worked closest to the aircraft, the connection between the modification and the outcome was direct, because they had seen the problem before the change and could recognize how the interaction had evolved after it. For the broader system, however, the relationship was more difficult to accept, because it implied that a solution had emerged from outside the established pathway, driven by practical observation rather than formal analysis. The result was not just a successful operation, it was a disruption in how effectiveness was defined, shifting the focus from adherence to procedure toward adaptability under real conditions. And within that disruption, the original decision to alter the aircraft revealed its full impact, not as an isolated improvement, but as the starting point of a chain reaction, where each successful engagement reinforced the next, gradually reshaping expectations and forcing the system to respond to a change it had not initiated and could no longer ignore. What followed did not unfold as a planned transition, but as a gradual shift that spread faster than the system could formally process or regulate, because once the results began to accumulate, they created a pressure that no report or recommendation could contain. Units that had struggled under previous methods started to observe similar changes when the modification was applied, and what had initially been treated as an isolated adjustment began to appear as a repeatable pattern across different missions and conditions. This was the point where the effect moved beyond a single decision and entered the realm of consequence, where each new outcome reinforced the last, making it increasingly difficult to dismiss the change as situational or temporary. The response from higher levels did not come immediately as acceptance, but as scrutiny, because the system needed to understand whether what it was seeing could be integrated without destabilizing the structures it relied on. Engineers who had not been present during the initial modifications examined the configuration from a distance, focusing on the same concerns that had been raised earlier: balance, structural integrity, long-term durability, and whether the aircraft could sustain those changes without introducing failures that would offset any tactical advantage. Their conclusions, based on established principles, suggested that the design pushed beyond acceptable limits, and from a controlled engineering perspective, that assessment was not unreasonable. What created tension was the gap between that assessment and what was already happening in operational conditions, where the aircraft were not only functioning but producing results that could not be ignored. This contradiction placed the system in a position where it had to reconcile two forms of truth, one derived from calculation and one from experience, and the usual process for resolving such conflicts, testing, validation, gradual implementation, was too slow to keep pace with the rate at which the new approach was demonstrating its effectiveness. As a result, decisions began to shift from whether the modification should exist to how quickly it could be standardized, without introducing additional risks. For Turner and others working directly with the aircraft, the change in attitude was noticeable not in formal announcements, but in the kinds of questions that started to replace earlier objections. Instead of asking why the modification had been made, officials began asking how it had been implemented, what adjustments had been necessary to maintain stability, how the added weight had been managed, and what practical steps had been taken to prevent the issues that had originally been predicted. These questions reflected a transition from resistance to adaptation, indicating that the system was beginning to absorb the change, not because it had been convinced in theory, but because it could no longer deny the outcomes that were already shaping operations. The process of scaling the modification introduced its own challenges, because what had been achieved through improvisation on a limited number of aircraft now had to be translated into a form that could be replicated consistently across a larger fleet. This required a different kind of expertise, one that bridged the gap between field innovation and structured production, taking the lessons learned under pressure and converting them into designs that could be manufactured, maintained, and operated within a broader framework. Gunn's role evolved in this phase, not as someone introducing a new idea, but as someone explaining how a practical solution could be aligned with the constraints of large-scale implementation. That transition revealed another layer of the original decision's impact, because it demonstrated that the value of the modification was not limited to a specific scenario. It had the potential to redefine how aircraft were used in similar contexts across different regions. As production lines began to incorporate elements of the design, the concept extended beyond its point of origin, influencing units that had never encountered the initial problem in the same way, yet now benefited from a solution that had been developed under entirely different circumstances. The effect was cumulative, with each new aircraft carrying forward not just the physical changes, but the shift in thinking that had made those changes possible. At the same time, the system had to adjust its understanding of where effective solutions could originate, because the path that led to this outcome did not align with its standard model of innovation. The modification had not emerged from a formal research process. It had not been approved through conventional channels, and yet it had produced a level of effectiveness that demanded recognition. This forced a reconsideration of how information moved within the system, highlighting the limitations of relying solely on top-down analysis and the importance of integrating observations from those who worked closest to the problem. As more units adopted the approach, the original decision began to lose its identity as a single event and instead became part of a broader transformation, one that altered expectations not only about what aircraft could do, but about how quickly those capabilities could change when someone chose to act on what they observed rather than what they were instructed to assume. The system did not collapse under that pressure, but it did shift, gradually incorporating a way of thinking that had once existed outside its boundaries, and in doing so, it allowed the consequences of that small, unapproved decision to extend far beyond the moment it was made. Years later, when the reports had been archived, and the numbers had been reduced to summaries, it became easier to describe what had happened than to understand how close it had come to not happening at all. The aircraft that carried those modifications continued to operate across the Pacific, influencing engagements in ways that were no longer traced back to a single decision, and the system that had once resisted the change gradually absorbed it until it became part of standard practice. What had begun as an unapproved adjustment made under pressure was now embedded in production lines, training procedures, and operational planning, its origin refining as its impact expanded. Gunn himself did not remain at the center of that transformation in the way the results might suggest, because the system had already moved beyond the point where any one individual could define its direction. His role shifted as the war progressed, shaped as much by circumstance as by choice, including the injuries that eventually limited his ability to continue flying. Those injuries were not the result of a single defining moment, but part of the ongoing risk that had always existed in the environment he operated in, a reminder that even as the system adapted, the individuals within it remained exposed to forces that no modification could fully control. At the same time, the personal dimension of his experience unfolded along a parallel path that did not follow the same logic as the operational changes. His family, held in captivity in Manila for years, existed outside the immediate scope of the decisions being made in the Pacific. Yet those decisions indirectly shaped the conditions that would eventually lead to their liberation. The connection between the modification and that outcome was not direct in a simple sense, but it was part of a larger chain of events where each shift in capability influenced the pace and direction of the conflict, affecting timelines, strategies, and ultimately the moment when control of key locations changed hands. When the liberation of Manila finally occurred, it marked a point where those parallel paths intersected, not as a culmination of a single action, but as the convergence of countless decisions, large and small, that had accumulated over time. Gun's reunion with his family was recorded as a personal event, separate from the technical contributions that defined his role in the war, yet the two were connected by the same underlying dynamic: the way individual choices, often made without full visibility of their consequences, could ripple outward and return in forms that were impossible to predict at the moment they were made. After the war, as operations transitioned back to civilian life, Gunn returned to a context that more closely resembled the environment where his instincts had originally developed, focusing on rebuilding and expanding an airline in the Philippines. In that setting, the same practical approach that had driven his wartime modifications found a different application, one centered on efficiency, reliability, and the ability to adapt systems to real-world conditions rather than theoretical models. The scale was different, the stakes were defined in new ways, but the underlying principle remained consistent, that effectiveness depended on how well a system responded to the conditions it actually faced. His life did not conclude with a clear resolution that matched the scale of his contributions, ending instead in an aviation accident years later, a reminder that even for someone who understood machines as deeply as he did, there were limits to what could be controlled. The system he had influenced continued to evolve, incorporating lessons that extended far beyond the specific modifications he had introduced, shaping how aircraft were designed and used in conflicts that followed, often without explicit reference to their origin. Looking back, the most difficult question is not what the modification achieved, but what might have happened if it had never been made, if the patterns observed on that flight line had been ignored or dismissed, if the decision to act had been delayed or prevented by the structures that were designed to maintain order. The war would have continued, strategies would have adapted in other ways, but the timing, the cost, and the sequence of events could have been fundamentally different, affecting outcomes that extended far beyond any single engagement. That uncertainty is what defines the true impact of the decision, because it reveals how much of history depends not on grand strategies alone, but on moments where someone chooses to respond to what they see rather than what they are told to expect. The system did not change because it was designed to. It changed because it was forced to by evidence that emerged from outside its usual pathways, and that distinction carries a lesson that extends beyond the context of war. Systems are built to preserve what they know, but they evolve when someone applies the right skill at the right moment and is willing to accept the risk of being wrong in order to avoid the certainty of repeating what does not work. Whether that kind of decision is recognized at the time or only understood years later may depend on circumstances, but its consequences will always extend further than the moment in which it is made.